Welcome in my DCK, ACR, ACI, AKS, and ACS session, or known as the Container Alphabet Soup. My name is Peter the Tender. Feel free to stay in touch and reach out if you have any questions by email peter@pdtit.be or using Twitter, where pdtit is my tweet handle. A quick introduction about myself. So my name is Peter, based out of Belgium, but traveling about 90% of my time across the world to provide Azure readiness training to customers and Microsoft partners. Been in the business for about 22 years, of which the last 5 years is Azure, and the last year and a bit been working with a lot of container workloads. So that's the main reason why I'm talking about this. Although the agenda is not really formal, let me start with a quick overview. So what I want you to get out of this session is getting an overview of why you could use containers in helping you to move to the cloud. And then obviously explaining all the different acronyms I started with at the beginning. And in between, going to do quite a lot of demos. Since we only have about 30 minutes, it's going to be more demos than talking, to be honest. And then Q&A during the MVP days. We have the Q&A active. Or later on, if you're watching this as a recorded session on YouTube, feel free to reach out on social media or email. There we go. Now, quite important, a lot of customers or partners are struggling with the main concept of containers. Now, easy said, containers are a lot similar than virtual machines. We've been using VMs for, about 15 years or so, where it starts from a physical server, the host operating system. On top of that, we deploy a hypervisor like Hyper-V or VMware, and within we're going to deploy virtual machines, where each and every VM runs its own workload. Now, if we map it with containers, there's actually a lot of similarities. We start with a physical server. On top of that, we deploy a host operating system, but then replacing the hypervisor with a Docker engine. On top of that, instead of deploying binaries, libraries, and specific workloads in a dedicated environment, we're going to share those and running specific containers, where each container is offering one specific task or one specific workload. And obviously you can combine multiple containers together to build like a multi-tiered application workload. Now, the main benefit, if you want, of using containers is the movability. Now, what I mean by that is that once you have your container standard, where Docker, I think, is probably the biggest one. Once you have your container from your local machine, you want to run it in Azure, you want to run it on top of a virtual machine, or you want to move it between Azure, AWS, Google, or any other private cloud environment, like Azure Stack, for example, you could also do that. So that's a quick introduction, like containers, how does it relate to virtual machines? Now, the core topic of the session is running your containers in Azure. Now, I'm going to start with the different services. Now, if we look at running containers in Azure, we got a full list of capabilities. You can deploy Azure containers, or you can deploy containers inside Azure Application Services. So where you would typically use app services to run web applications, instead of pushing out the source code, you're going to push out a container and running it from there. Service Fabric is another option. It's like the Kubernetes of Microsoft, if you want, allowing you to run .NET-based applications, but also supporting containers end-to-end. Then Kubernetes, I'll talk about it a bit more towards the end of the session, but it's probably the standard in running professional, high available, super scalable containerized workloads, where Kubernetes is initially developed by Google, but somehow made as an open source platform, and that's partly why it's so popular. And it's also available across different cloud environments. Another option within Azure is Container Instance, where it allows you to easily set deploying the container and running it as a standalone instance. So not having that full orchestration that Kubernetes gives you. And outside of these, like I would say the core native Azure environments, to run containers, we also have a full list of partner application platforms supporting containers as well. Like Docker gives you Docker Enterprise, or Docker Swarm, you got OpenShift, you got Mesosphere, so quite a lot of different environments. Now, partly mapping it with the acronyms I'm using in the beginning. So app services would be apps. SF is Service Fabric. AKS is Azure Kubernetes Services, and ACI stands for Azure Container Instance. And then two main services at the bottom, we got Azure Container Registry and Docker Hub. Azure Container Registry is like the landing page, the source environment, where you're going to store offline images. So the first step, and I'll walk you through a demo later on, but one of the first things you have to do after building your containerized application is pushing it out to Azure Container Registry. Another option besides using your public container registry is using a public Docker Hub, where honestly a lot of vendors like Microsoft, Red Hat, Node, and all the other ones, Apache, are publishing public containers that you can just grab and reuse from there. And that brings me to two other acronyms, ACR, Azure Container Registry, and Hub for the Docker Hub. So with that, you know most of the acronyms we're going to use throughout the session. And again, it's all pointing at Azure and containers. Now, the baseline for containers is Docker. Docker is not the only option you have available, but it's probably the most popular one. It's an open source platform, and it's multi-platform aware. So it allows you to not only run it on different cloud platforms or on-prem private cloud environments, but it's also cross-platform in a way that it allows you to build Windows containers or Linux-based containers. So pretty cool stuff. Some intro on what Docker looks like. So one of the first things you need to know is the Docker command line. So you got a few common settings like Docker pull to pull down your source container from the Docker Hub, Docker run to start up your container, Docker build to containerize your application starting from the source code. And then in the middle, you got your host, where again, you got a full set of options available, where you start from offline images inside the registry, and from there starting them up, and they become a container. And that's the main source where you can grab those containers. So the first one is Docker Hub. A second one is creating your own Docker host and storing it from there. Now Docker Hub, let me quickly show you in a demo what it looks like. So if you connect to the hub.docker.com website, you can explore, and immediately it's going to show you a list of close to like 2-point-something million available images, where you can define, maybe first of all starting with verified publisher. So these are from like official vendors, but it doesn't mean that all the other ones would be like not safe to use. But obviously the ones coming from official vendors like Microsoft, like Oracle, as you can see here. If I move down, like Veritas, and again you got like 2 million of them, where the official ones are not even 2 million, like 260. Another option would be searching for what you need, like Node, for example. That gives me an integration with Mongo, an integration with iOS. Let me take this one. And this is the official Node container. So that's really how easy it is to find them. Next to that, you can build your own custom images, like a baseline for your applications, where if you look at a Docker image, and I'll show you that in a demo that's upcoming. If you look at a Docker image, it's really based on a layered cake, where you start with an operating system, the binaries, and on top of that, a layer for your specific application workloads. And again, Docker Hub is mainly used for public images, like what Node.js is sharing, Oracle is sharing, Microsoft is sharing, and the Docker host would be used for your private ones. Now, once we have this container, we're going to run it, because obviously otherwise we don't really have an application running. So one example here, Docker would be calling the command line option, run to perform a run activity. And then you have a couple of parameters, like IT would be interactive, so you can at least see something on screen, like what is my container doing, pointing to the name of the container, and besides that, all the way at the end, you're going to define what is the command I'm going to execute within my container. Some other comments, but I'll walk you through in a demo. So let's start with that. Now the assumption is that you run your Docker engine, you download it from the Docker website, you can run it on Windows machine, Linux machine, on a Mac environment, Windows server, Linux server, doesn't really matter. So from here we're going to start with Docker info. It's like a basic command that actually tells us what the version is, how many containers we have. So it's quickly checking if your Docker engine is actually running fine. So next to that, we're going to do the Docker run interactive Ubuntu, which is the name of my container. And besides that, I'm going to run my bin bash. Now it tells me I can't find Ubuntu, and next to that it also tells me no matching manifest. So something seems to be wrong. So what we can do here is Docker images, where I got quite a lot of them from the last couple of days and weeks. And what I can see here is that I have a few pointing to ASP.NET web application. So one of the cool things is, since I'm running my Windows client, I can actually mix and match Windows containers together with Linux containers. Now, if I do Docker run hello world, this one already runs on my machine. And the only thing it does is literally showing this text output. So that's a Windows-based container. And the only thing it does is showing you some text feedback, but it's always a nice check. Now, what about this Ubuntu container? Obviously, since my Ubuntu is somehow Linux dependent, I need to switch to my Linux environment. Now again, one of the interesting parts, since it's running on Windows, is out of my Docker daemon, so this little icon up here, I can now switch to Linux containers. This is going to take a couple of seconds. And if I do Docker images again, you can now see that it's having different images. The previous list was Windows-based, this is a Linux-based. So if I do the same, I'm going to run my Ubuntu again. Then it's again telling me I don't have it local, so it's going to connect to the public Docker Hub. And as you can see, it's based on 4 different layers. So what I talked about in the layered cake is literally what you can see here. So it's going to download and eventually it's going to run it. So I'll keep it just running for a couple of seconds. Now, downloading a public Docker Hub is obviously interesting as a starting point, but most environments actually want to build their own custom images. You start with the source code, and then you're going to run a command called docker build, where you point to your source folder where you have your application coding, and it's going to create this new container. And you can already see a couple of screenshots, but obviously we're going to show you live how this is working. Now, the magic in building your Docker container is out of a parameter file called DockerFile. So you create a DockerFile, it's like a text file, in which you define a couple of parameters. Now, there's a lot more than what you can do with what I'm showing here, but easy said, in the first part, in the from section, I'm going to tell that my base operating system within the container is, in this scenario, ASP.NET using Windows Server Core and using the 2016 edition. Next to that, I'm going to add everything from a folder on my local machine called WebVM sample site and copying that inside the container into the inetpub wroot folder. So basically the default IIS folder if you want. And then lastly, by using the parameter expose, I'm going to define that once my container is running, it's going to start IIS, probably pretty obvious out of this ASP.NET container, and it's going to run the website on port 80. Now, another option if you're a Windows developer or a Linux developer, I mean, in the end, the platform again doesn't really matter, but one of the nice integrations is Visual Studio, allowing you to actually speed up the whole process about building. So instead of memorizing all the commands, you can just launch Visual Studio, where in meantime here in the backend, my Docker container is complete. and it's already running. So I can validate it down here, and if I do Docker container list, oh, it's not working. Why not? Hey, way cool. Remember up here I did Ubuntu and then bin bash, so I'm actually inside my container. So if I do ls here, I'm actually within that Linux operating system. So I can exit from here, and then I'm not inside my container anymore, where if I do Docker container, I didn't keep it, list, it's going to show me my running containers. There's nothing running anymore, obviously, since I killed it. But by using the -A, I can get a list of previous running containers. So always interesting for troubleshooting. And then I can find my container up here. And that's one started about 2 minutes ago. Cool. Now back to Visual Studio. So I'm going to create a new ASP.NET based application. Now, since I'm running Windows and Docker together, I can enable my Docker Compose here. But before I do that, I actually need to switch back to my Windows-based environment. There we go. I'm still amazed that this is actually working so easy on the Windows platform, like literally mixing the two environments together. Just gonna give it a few more seconds. Seems to be okay. There we go. So it's pushing in some ASP.NET sample code. And once my code is live, it's automatically generating that DockerFile as well. So up here, as you can see, it's using something similar than what I showed you in the screenshot. So it's going to start with the ASP.NET source container, grabbing from the Docker Hub, and then using this initpub folder as the work directory inside the container, and copying everything from within my source, so all my source code up here on the side, and copying that inside my container. And in just a few seconds, as you can see here in the logging, it started with creating step 1, then moving to step 2, step 3, copying, and step 4 tells me my container is ready. So if I run my Docker images again, somewhere from a few seconds ago, I think it's probably this one, not that important. I didn't specify any specific name for that, but that's probably the one. Another option, or I'll talk about it later on. Cool. So that's how you can easily build your Visual Studio. And again, you don't have to use Visual Studio. You could all do the same using command line, but it's a nice way. So now we're at the stage where we have our local container. We could run it locally, testing it out. Everything's running fine. And the next step is moving to Azure. So the first component we need is Azure Container Registry. So we're going to grab our container and pushing it out in the registry. And from there, we got a couple of options. Running it as a standalone one in Azure Container Instance, running it in Azure Application Services for Containers, or moving to the full orchestration with Kubernetes. So ACR, the container registry, your landing page for storing your containers. These are cross-platform, so once you have your registry available, it's going to be used by any of the other container services I already talked about. Deploying a new one is pretty straightforward. So from your Azure portal, you complete container registry, where it's going to ask you for a unique name, the location, and what SKU you want, where the SKU is mainly pointing at performance, data storage, and high availability. You could do the same using PowerShell, using CLI, pretty obvious, like most other Azure environments. And then from here it gives you that ACR object. Now this one is empty for now. So if I go to my repositories, there's nothing in there for now. Now to speed up the demo a little bit, I already have another one available. And if I check back here, I got my container in there. And you'll find out later on where this container is actually coming from. Cool. So the next step is running our container. The registry is mainly your location where you're going to store offline images, but from here we want to run it. Running your container in like a standalone option would be Azure Container Instance, where it literally allows you to start from the container registry, selecting the container and starting it, where you're going to define what is the performance like CPU memory power I want to give to that specific instance. The other advantage is that you can shut down your instance when you don't need it and you don't have to pay for it. And on top of that, the billing is based per second. So it's typically used for like short running workloads. So moving on and running our container. So from here, I'm in my registry, select my container, and I'm going to run my instance, where you need to provide a name, MVPDays container. This is my source image. It's a Windows-based one. Where do I want to store it? Inside my MVPDays resource group. Number of cores, I can build pretty powerful containers. And why not providing public IP? So this is going to grab my container from the registry, moving it into container instance and running it. Where something's wrong. That's the fun stuff about doing live demos. Let's see. It doesn't support Windows. Okay, my mistake. So we're going to do this once more. I told you it's nice to have this mixed environment, but sometimes it's a little bit complicated. So Linux, everything else is fine. Cool. Don't be too fast, Peter. Pay attention. Come on, you can do this. There we go. Gonna give it a few seconds to make sure it's not failing. Looks better. Cool. Keep it running for now. Another option is using Azure Web Apps. If you're a little bit familiar, and maybe some of you watched one of my former MVP sessions on Azure Web Apps, EasySet allows you to run websites, Windows-based, Linux-based, supporting Node.js, Apache, and a lot of Java, a lot of other angles there. Now again, instead of running your source code inside web apps, you can now run your container as a web app. So it gives you all the beauty of web apps, on top of that allowing you to run containers. And it's not giving you the full orchestration, but in my opinion it's better, or at least giving you some more admin operations than ACI. And since it relies on web apps as the platform as a service component, it supports high availability and scalability as well. So let's try one more demo here. Web app for containers. We're going to ask you a name and a couple of other basic settings, the resource group, what operating system you want to use, and what your container should look like. Now, if all goes fine, I already have one up here. So I got my web app. Some of you might remember basic web app configuration settings. And besides that, I also have container settings. So this is something specific to web app for containers. So you don't have this option in the typical web app environment. On top of that, it's providing a unique URL. And if all goes fine, this container should be running in the meantime. Sometimes it's first showing you like a warning page where it's starting up the container, but since this one was already running a little bit to speed up the demo, you can see that it's running my ASP environment and using these Windows containers. So pretty nice. Let me in meantime check back in my container instances. I got my MVPDays, it's running. And since I enabled public on port 80, I could actually try it out and connect to this one and see what's happening here. Cool. So this is a Linux-based ASP.NET container that's running out of container instance, grabbing it from the container registry. So we're moving on. Up till now we have standalone containers running, but what if you need auto-scaling, like moving to multiple containers? If you want to perform rolling upgrades from one version to another, if you want load balancing, scaling options, everything that makes it like a full, proper, professional, production-ready environment. In short, what you need is an orchestrator. Now, I already talked about some of the options where out of 15 slides back with all the different container options, the important ones when talking about orchestration is Kubernetes, Mesosphere, Docker Swarm, and Service Fabric. All of these can run on the Azure platform. So you got Kubernetes, Mesosphere, Docker Enterprise, and the native Microsoft flavor would be Service Fabric. So all of them are supported on Azure. Now the first step you need to do is deploying your Kubernetes cluster. So you can use command line, Azure CLI, AKS, where you provide the resource group, the name of your cluster, how many nodes you want in the cluster, and once the cluster is up and running, you need credentials to connect to it. So it's all end-to-end secured as well. Instead of using command line, you can also use the Azure portal. So similar to any other Azure resource deployment, it allows you to define some parameters and running it from a portal-based deployment. It takes about 10 minutes, and once the cluster is deployed, you can validate the different Azure resources. Once you have your resources available, managing the cluster itself is relying on kubectl, kubectl, or kubectl. You got a couple of expressions there. I personally like kubectl, and that's like a built-in Kubernetes command line to manage your cluster. Back to a demo. I got my Kubernetes service. There's already running and showing you how easy it is from the portal nowadays. This is really it. So you provide a resource group, you provide the Kubernetes cluster name you want, what version of the cluster, and they're going pretty far back. And then down here you define what is the underlying virtual machine size that I want, and you can scale from like one standalone node, but that wouldn't give you any high availability. So that's why the default is 3, and you can build up to 100 in a single cluster. So it should be more than enough. So once you've done all that, you have your Kubernetes environment up and running. And from here you can do some management. One step I'm not going to show you because I'm running a little bit out of time is pushing your containers into the Kubernetes cluster. And for that you would need, similar to the DockerFile for building one, you would build a Kubernetes YAML file. Now I'm not going to push it out, but I can actually show you what it looks like. So in here, you define this is the name that I want to give for my running container. And most important is this option here. What is your source image and what is the port it needs to run on? So similar to the instance I showed you before, you build this text file, you can grab samples from the Kubernetes website or from GitHub, and basically you provide a name for your running container inside Kubernetes and grabbing this specific image. The other nice thing you have is end-to-end Azure monitoring. So you got a built-in monitoring information allowing you to inspect your nodes. So this was a cluster based on 3 different nodes. like 3 virtual machines if you want. And from there, you can drill down and getting a view on all the other layers. And then lastly, you're running containers. And I know my portal is a little bit weird in the recording resolution, but I can select any of my running containers here, and it's providing me some feedback as well. Last thing before closing out is using Visual Studio Code. So what you can do is installing Docker extension, the Kubernetes extension, and from there managing your environment. So instead of memorizing commandlets by heart, it's just using Visual Studio for that. So as you can see here, it's recognizing my cluster, and from here I could get a view on the nodes, the network information, and so on. Other options I have, let's say I go back to my source environment where I build that container. Instead of using Visual Studio or using command line, once you have your extension deployed, you can open up the command palette. And as you can see up here, you got a few Docker options. So Docker build image, some updates available here that I don't need, provide me a name. And it's launching this Docker build command, where it's gonna grab information from the DockerFile and already having my container available. Next, I want to push it to ACR. So I can do Docker ACR, and from there, building it out, pushing it out, or why not running it from here to validate. So nice integrations there. One of the other options, and this will probably become another MVP Day session in the next couple of months, where I'm going to show you how you can deploy Windows, Node, Kubernetes, where for now it's all based on Linux, but Microsoft made it available since March 30th, so only a couple of weeks back, that instead of the virtual machine nodes in a Kubernetes cluster are Linux-based, they're also Windows-based, and they rely on Windows 2019 and allowing you to deploy full Windows-based line of business applications. So pretty cool stuff. If you're watching this and you're already interested in getting the details, send me a mail, peter@pdtit.be, or shout out on Twitter, and I'll be more than happy to provide you a lab guide on how to deploy it. So that was my session on the container alphabet soup, where I talked about Docker, Azure Container Registry, Instance, and Azure